Hi everyone. So continuing with the last lecture where I explained about the OSI model and the seven layers, let's continue with the lecture two on the network layer. Uh, I want to explain more on the network layer. It may take like next 8 to 10 classes, but if you get a good grip on this layer, it will be very easy for you to understand the other networking concepts. So yeah, let's begin with the network layer. In this lecture, I want to give just the basics on DNS, domain naming system, and the binary system, which is bits 0 and 1, and the IP, introduction to the IP address, specifically IPv4. So yeah, let's start our lecture. So, as I said in the last lecture, uh, whenever your packet travels from one network to the other network, you have your routers in between. Like there are so many firewalls, so many restrictions. Each firewall is designed to have its own rules, restrictions, firewall because completely different network. So, suppose you have your network one here and you have your network 2 here. I want to explain the basics of how a packet travels or how a request goes from one network to the other network. So your network 1 may be in one country and your network 2 may be in a different country. Like the computer you are requesting uh, in network one maybe in one country and the server or computer two or host, let's call it a host or a server or computer host or what you can call whatever server may be a different country, and you may have like many routers in between because as these are in two different networks. This is your network. Suppose it's your house, you're requesting something and you have your own ISP, internet service provider, and you have your own router here for the internet service provider. So yeah, suppose you are requesting something from computer one or host in one network and you want to talk to a host in network two. So it takes place in three steps. Suppose you're requesting a cnn.com or a youtube.com. Let's say it's a cnn.com requesting something. It comes sitting in your house in your own network from computer one. So the first step is it has the packet or the request goes has to go from this network all the way to this network. It's just the network. It did not go to the host in network 2. So this is step 1. So step 1, your request or your computer talks to network 2. So from network 1 it goes to network 2, your request. And step 2, it goes from it goes within the network, it goes to the particular host. Let's call it host x, host y in network 2. So from here host x, within a network it sends the request or it talks to host y in network 2. This is second step. And the third step is it has to go to the particular application using the protocol, the application protocol. Here it's cnn.com http https, and it requests cnn.com. So step 3, once it goes to the host y, the application protocol comes here, protocol, and here it requests cnn.com http. So the step 1 is the request goes, or the computer host X in network 1 sends it to network 2, and second step is within the network 2 it goes to the particular server or the host Y in network 2, and step 3 is whatever application it wants to look for, like cnn.com or youtube.com. So I can explain you about more about on step 3 here, just the basics. So it each application protocol has its own port number. So it here it requests when I say it requests its cnn.com, it takes it takes a port number with it. So cnn.com is https it's a port 80, and if it's protocol, your application protocol is FTP, I guess it's a standard 21 port 21. So SMTP is one more application protocol which is 25. So just don't worry about this, we can talk about this in the next lectures, but just to for your information, in the step 3 each application protocol has its own port standard port number. So your request goes from one network to the other network, which is step 1, and the step 2 it goes to the particular server you are looking for. Here it's host Y, and the third is based on the application, it takes its port number and requests the particular in on the particular port. And yeah, so let's talk about the DNS here. So as I said here, when your request goes from network 1 host X wants to talk to network 2 host Y, and I said it's requesting cnn.com, right? So step 1, this step 2, and here it's a port. Step 3 takes its port. Step 3. So host X request cnn.com. So whenever you request something, or whenever computer wants to talk to the other computer, it converts into a sequence of numbers. So computer cannot understand the cnn.com or youtube.com. It has to convert it into sequence of numbers in which the computer understands. So let's say it's a set of some numbers which is called IP address. So it converts cnn.com or whatever request you are putting here is converted into a sequence of numbers called IP address, and this conversion takes place in some DNS server. So DNS server is within your network. So the service is provided by your internet service provider. For me it's a Comcast. So in your DNS server, your request, whatever you request, it's converted to IP address, which is a sequence of numbers, and those numbers are carried forward for looking for the address in the network 2 for the host Y. So the first request might take time because the first request may be late, but your second and third request may be very fast because it's the IP address of the particular request is already stored in the computer. So second request is quick, but the first request generally it would be late, and it's called DNS overhead. But I hope you understood the basic concept of DNS here. So whenever you request your your computer requests something, it changes it's a request particular request into IP address, so which is a sequence of numbers, and using the IP address it goes and finds the address of the particular host with the port number in the different network. So this is the concept of DNS, and as I said before, the DNS, the service is provided by the your internet service provider, which is just located within your network. So your request is converted to sequence of numbers to look for the address in different network, for the different host in the different network. And here I have to explain you something called a number system before we go forward. So I told you the IP address is the sequence of numbers, right? So let's talk about the numbering system here, then I'll talk more on the IP address. So number system. So the number system which we use in our regular life is uh, it's a decimal system, right? Decimal system where we have 0, 1, 2 up to number 9. And previously it used to be only a unary system where you have only one number, which is 0. So for 1 it's 0, for 2 they used to call it 0, and for 3 it's 0, 0, 0. Then came binary. Binaries, they have only two numbers, 0 and 1. Then suppose if it's octa, then it's 0, 1, 8 numbers till 7. And in the regular life we use decimal, which is 0, 1, 2 till 9. And suppose if it's hexa, it's 0, 1, 2 till 16, so till 9. And then comes A, which is 10, B, C, D, E, F. But yeah, so these are the numbering system. And for computer to understand the computer language, it takes only the binary. So whatever request you send, it has to be either 0 or 1. So that's what I'm coming to, like your IP addressing here. IP addressing, I told you, right? It's a set of numbers. The DNS converts the request, suppose cnn.com, to the IP address. So it's a sequence of numbers with zeros and ones. So the language which computer understands is binary, which is the combination of 0 and 1. And here I want you to get a good grip on binary to understand the network layer, all the networking, how the data packet travels and everything. You should have a good grip on binary. So you should know 2 power 0, 2 power 1, 2 power 2, values 2 power 3, values of all these numbers, 2 power 10, which is 1024 mega, 2 power 20 giga, 2 power 30, and tera, 2 power 40. So I request you to get a good grip of all the binary numbers, because it will really help you in understanding the IP addressing.